Hello everyone, we are the final year students from the Department of Civil Engineering in AMC institutions, and our team members are Abbas, Dipesh and Nadeem, and our project name is Design of a seismograph in a residential building. Our
Now let's discuss about some objectives of the project. The major objectives of our project are first one is to monitor the earthquakes, detecting and analyzing the intensity, duration and the location of the earthquake. Second one is understanding Earth's interior, providing insights into the structure of composition of the Earth's interior. And third one is early warning systems, contributing to the systems that can warn about impending earthquakes or volcanic activity. Fourth one is research and education, supporting scientific research and education in geophysics and seismology. Yeah, coming to the literature review of the project, basically we have gone through some journals or papers for the study, and the first one is anomalous behavior of precursor reactivity in Shillong Northeast, and this paper was published by J.R. Kayal and B. Banerjee in the year 1988. The major findings from the paper were daily measurements of apparent from 1984 to 1985 on Shillong Plateau. Second paper, entitled A Model of Household Preparedness for Earthquakes, was published by J.S. Becker, D. Patton, D.M., John Stone, and K.R. Rohan in the year 2012, and the major findings from the paper were the study presents a model of household preparedness, emphasizes psychological and social factors that affect readiness for seismic events. Third paper, entitled Seismic Hazard Analysis in Urban Areas Using Advanced Technologies, was published by L. Wang M. and Zhang in the year 2015, and this paper explores the use of advanced technologies such as AI and IoT for seismic hazards analysis in urban areas. The fourth paper, entitled The Role of Public Awareness and Education in Earthquake Preparedness, by A. Smith, R. Brown, and E. Davis in the year 2017, it was published, and the major findings from the paper were investigate the impact of public awareness and educational programs on community preparedness for earthquakes.
The components that are being used to prepare a seismograph is a wooden frame with a stand, bolts and nuts of 4 mm, copper wire without an insulation, an electric buzzer, 2 number of 9-volt batteries, 150 ohm resistor, LED light, gear motor, pulley, paper roll, marker and a sunboard. Methodology: the designing of a seismograph in a residential house and the preparation of a model of a residential house. Then the design process of a seismograph in a residential house. The fixing of a components and the circuit connections are being done. Then the fixation of a seismograph beside a model of a residential house, and the collecting of a data in the form of a graph.
Now let's discuss the working of the circuit diagram. In circuit diagram we can see the two subsystems, that is the left subsystems and other is the right subsystems. In left subsystems we have the gear motor, battery and switch. In that the battery we are using the 12-volt battery for the supply purpose to the gear motors, and the switch for the turn on and off purpose. In the right subsystems we have switch, battery, LED light and resistors, and the buzzer. In that the battery we are using, that is 9-volt battery, and LED light for the indication purpose, and the resistors to resist is used for the limit the current to the LED, and the buzzer we are using for the emits sounds when the seismograph detects vibrations, and and for the connection purpose we are using the both subsystems are connected to the ground at the central point, and the switches in each subsystems allows the independent control over the motor and the electronics indicator components, that is the LED and the buzzer. So let's see how it works. So first, motor subsystems. When the switch in the left subsystem is closed, the 12-volt battery powers gear motors, which drives the mechanical part of the seismograph. Indicator subsystems. When the switch in the right subsystem is closed, the 9-volt battery powers the LED light and the buzzer. The LED light will turn on, indicates the system is activated. If the seismograph detects the vibration, the buzzer will sound to the alert the users. Now let's see the conclusion of the project. Customization of the residential use. The seismograph systems must be designed specifically in the unique requirement of the residential environmental, including the sensitivity to the lower magnitude area and also the sensor placement. Strategic placement of the sensor within the house of the crucial for the accurate data collection and the effective monitoring of the seismic activity, ensuring the comprehensive coverage and the early detection. User-friendly interface. Developing a user-friendly interface for the homeowners to easily monitor the seismic data and receive real-time alert, enhancing their ability to respond promptly to the seismic event. Integration with the home systems. Seamlessly integration with the existing home automation and the security system to provide the automated response, such as the shutting of the gas lines and the electricity to prevent the secondary hazards. Cost effectiveness. Ensuring the seismograph systems is affordable to the homeowners with the low maintenance requirement and the reliable performance over the time. These are the conclusions for the seismograph projects. Thank you.